Good day, kids. Welcome back to our video lesson. Once again, my name is Teacher Manu Palabio, and today we will be discussing about electromagnetism. We will find out what is electromagnetism, what is magnetism, and what are the different types of magnets, as well as how to produce an electromagnet. This lesson is taken from the most essential learning competency in Science 5. I know you're ready. Now let's begin. What is magnetism? Magnetism is the property of interaction of magnets. It is also the property of attracting certain metals. It is a class of physical phenomena that include the attraction for iron observed in lodestone and a magnet, are inseparably associated with moving electricity, are exhibited by both magnets and electric currents, and are characterized by field of force. There are different types of magnets. There are disk magnets, U-magnets or horseshoe magnets, there are bar magnets, and many more. The term magnetism was coined or was first used in the year 1616. Magnets have two ends or poles, called North Pole and South Pole. At the poles of a magnet, the magnetic field lines are closer together. Let us look at the pictures. There are three kinds of magnets: the bar magnet, the disk magnet, and the U-magnet. All magnets have north and south poles. The magnetic field lines around horseshoe and disk magnets are closest at the magnet poles. Unlike or opposite poles of magnets attract. Again, unlike poles or opposite poles of magnet attract with each other, and like poles of magnets repel. Opposite poles like North Pole and South Pole attracts, while like poles like South Pole to South Pole or North Pole to North Pole of magnets repel. How do magnets found? The earliest magnets were found naturally in the mineral called magnetite, which is abundant in the rock-type lodestone. These magnets were used by the ancient people as compass to guide sailing vessels at sea. Magnets produce magnetic forces and have magnetic field lines. Objects that are attracted to a magnet are called magnetic objects, and those that are not attracted to a magnet are called non-magnetic objects. What are magnetic domains? Magnetic substances like iron, cobalt, and nickel are composed of small areas where the groups of atoms are aligned like the poles of a magnet. These regions are called domains. All of the domains of a magnetic substance tend to align themselves in the same direction when placed in a magnetic field. These domains are typically composed of billions of atoms. Look at this picture. A normal iron nail is made up of billions of domains that are arranged randomly. The domains will align themselves along the magnetic field lines of a nearby magnet. What is the relationship between electricity and magnetism? When an electric current passes through a wire, a magnetic field is formed. When electric current flows through a wire, a magnetic field forms around the wire. the direction of the magnetic field depends on the direction of the current in the wire. What is electromagnetism? Electromagnetism is a branch of physical science that deals with the physical relations between electricity and magnetism. It is a simple device that can show how electrical energy is transformed into mechanical energy. An electrical energy received by the electric fan is then transformed into mechanical energy. That's basically the reason why an electric fan gives us cool air. An electromagnet is a magnet that can attract certain materials like iron or steel, nickel, and cobalt. The electromagnet operates on the principle that an electric current flowing through a wire coil produces a magnetic field. For instance, imagine a long straight wire and a certain long iron. Tie the wire around the iron to produce many wire coils which resemble a spring. Make sure, however, that the end of the wires are loose and are not coiled. After having made several coils around the nail or around the iron, what you have formed is a wire coil. That is being illustrated by the two illustrations. Now, connect the loose ends of the wire to the terminals of a battery. This will produce a current that will flow through the wire coil. As the current is flowing through the wire coil, a magnetic field is generated around the coil. A battery causes an electric current to flow through the coil of the electromagnet. The battery that we will be using here is a dry cell. If we put the iron with the wire coils wound onto it near a paperclip, the paperclip would be attracted to the nail as if the nail is a magnet, or the iron is a magnet. Actually, the electric circuit consisting of the battery, the wire coil, and the iron or the nail has produced an electromagnet that is being shown in the illustration. The electromagnet converts electricity into magnetic forces. This is the principle behind electric fans, washing machines, and many other appliances run by a motor. The electric current that enters the electric fan passes so many wire coils. Because of this, a magnetic field is generated. This magnetic field produces a magnetic force that turns the fan blades, and that is made possible because of electromagnetism. Again, electromagnet converts electricity into magnetic forces. Let us focus on this illustration. This picture shows an example of electromagnetism. A battery causes an electric current to flow through the coil of the electromagnet. Unlike poles or opposite poles of the two magnets attract with each other, and the like poles repel. This causes the coil to rotate until the opposite poles are next to each other. Now I want you to answer this activity. Choose the letter of the correct answer. Alright kids, Good job. Very good. Now you're good to go. I know you already know what is a magnet, what are examples of magnets, how to create electromagnetism, and what is electromagnetism. Now once again, my name is Teacher Manu Palabio saying, God bless you, Mama Mary loves you, and I likewise do. Goodbye kids. See you on my next video lesson. Bye.